Good morning, class, and welcome to your third week of virtual learning. This week, we're going to be starting our actual very last unit of the year, which is probability. So just to start off, what is probability? So you guys have probably heard this term when it comes to like rolling a dice, playing with cards, all of that stuff involves probability. And to put it simply, probability is, I'm going to share my screen here. Let's see, probability is equal to the number of ways something can happen divided by the total number of outcomes, okay? So put simply, if we put this in terms of, let's say, like a dice, okay? I could say that, and I'm going to go ahead and show you an example on my screen. So I can say that the total number of ways that I can roll a 1 on a dice. Now there's only one side of the dice that's labeled 1, but there are 6 possible sides that I can roll. So the number of ways that I can roll a 1 is 1, and the number of total outcomes is 6 because of those 6 sides. There's only one way I can roll 1, and I rolled a 3. I did not get it. So we could say that the probability of rolling a 1 on a dice is going to be one way of rolling a 1 over 6 possible outcomes. So the probability of me rolling a 1 is 1 out of 6. Okay, let's take another example. Let's use now a deck of cards. Okay, so let's say I have a deck of cards and there are 52 cards in a deck. If you guys have a deck of cards at home, it would be really easy to use that to help you through some of these examples. Okay, now the probability of me choosing the 10 of hearts from a deck of 52 playing cards. Well, there's only one 10 of hearts. Okay, you can see that. There's only one 10 of hearts in a deck of cards. So the probability of me drawing a 10 of hearts is 1 out of 52 cards. Now that probability changes if I broaden what I'm trying to pick. Let's say I want to pick a red card out of a deck of 52 cards. Now in a deck, half the cards are red and half the cards are black, which means that the probability of me, share my screen again, the probability of me drawing a red card, if half the cards, so let's say, probability of drawing the 10 of hearts was equal to, and we said that there's only one 10 of hearts in a deck of 52 cards, so 1 out of 52 cards. Okay, now this is going to be different. I said I want to draw the probability of drawing a red card. Now, if half of the deck is red, that means that only 26 of the cards are red. So I have 26 ways of drawing a red card out of 52 playing cards. Okay, so that's kind of an example of how probability would work when we're using a dice. We can use it with cards. You could also use it with something like the probability of picking a pencil or a marker. Okay, I have 4 pencils in my cup and I have 6 utensils in total. The probability of drawing a pencil is 4 out of 6. And the probability of drawing a Sharpie is 2 out of 6. So that's just basic probability. Now what you're learning this week are 2 different types of probability. The first one is called an independent event. An independent means like when you're independent, you don't rely on someone else. And so with an independent event, the probability of one event does not affect the probability of another. So for example, Let's say the probability of me rolling a 1, I didn't get it, does not affect the probability of me drawing a pencil, okay? They're two just separate events, okay? Now, similarly, if I just had one thing I'm trying to find probability for, the probability of me drawing a pencil is 4 out of 6, because there's 4 pencils, 6 utensils. Okay, so I draw this. And then I put it back and I want to draw a pencil again. The probability of me drawing a pencil the second time around is still 4 out of 6. So if I put something back in the jar, it doesn't affect my probability, okay? And we calculate the probability of independent events by multiplying both probabilities. Okay, so I'm going to show you an example just with the pencils that I just did. Okay, so again, I said that I had 6 utensils in the jar. So I'm just going to go ahead and erase the general examples of probability. And we just said that we're talking about independent events. One event, or we'll say the first event doesn't affect the second event. Okay, so let's say that I have this jar again, okay, and I say the probability of drawing a pencil, putting it back so it's independent, and then drawing another pencil. Okay, so the way that we would calculate this type of probability is we'd say, okay, first off, the probability of me drawing a pencil from this jar was 4 out of 6, because there were 4 pencils out of 6 utensils total. Okay, when I hear and then, that means I'm putting this pencil back in the jar. And now to find the probability of drawing a pencil again, well, I put the pencil back in the jar. So I still have now 6 utensils and only 4 of them are pencils. So the probability of me drawing a pencil again is still 4 out of 6. Okay, so the probability in total of me drawing a pencil and then putting it back, drawing another pencil, it's 4 out of 6 times 4 out of 6. On top, we multiply our numerators. 4 times 4 gives me 16. In the denominator, 6 times 6 gives me 36. So the probability of me drawing a pencil, putting it back, and drawing another pencil is 16 out of 36. And of course, you would have to go ahead and simplify this. It would simplify down to, let's see, if we divide both of those by 2, 8 out of, I don't know, you guys simplify it. All right, and so the next type of event, so independent events, the first event does not affect the second event. Now, the opposite of that is dependent events, which you can probably guess. Dependent events, if it's the opposite, means that the first event does affect the second event. Okay, so for example, let's take my cup with pencils and markers again. I draw a pencil out for my first event. I don't put it back. What's the probability of me drawing a pencil again? Well, now I don't have 6 utensils in here. So first of all, it was 4 out of 6 for a pencil, the probability. Now I only have 5 left. So the probability of me drawing a pencil again is 4 out of 5. So your outcomes change the second time around, okay? So let's go back to our example. And let's say for a dependent event, the probability of drawing a pencil, not putting it back, and then drawing another pencil. Okay, so just like the first event, we know that the probability of drawing a pencil was 4 pencils out of 6 utensils. Okay, but the difference is that I didn't put it back. So now, my second time around, the probability of drawing a pencil is going to be, well, there still might be 4 pencils in there. Okay, we don't know what we drew the first round. So 4 pencils out of how many utensils are still in the jar? 5. Okay, so it's 4 out of 5. And this is an example of a dependent event. So another example would be like if I drew a card out, I didn't put it back. How many cards am I drawing my second time around? 51 instead of 52. Okay, we're still going to multiply this the exact same way. So on our numerators, 4 times 4 gives us 16. But in the denominator, instead of 6 times 6, we have 6 times 5, which is 30. Okay, so you'll see how our probability changes for a dependent event. Okay, so there you have it. Again, just to kind of sum up what we talked about, so probability is just the number of ways something can happen over the total outcomes. So my chance of rolling a 3 is 1 out of 6, only one of the sides is a 3. Okay, an independent event means, let's use cards here, the chances of me drawing the Jack of Spades is 1 out of 52 cards. Okay, so I draw a Jack of Spades. I put it back for an independent event. The chance of me now drawing the Queen of Diamonds is 1 out of 52. There's 1 of a Queen of Diamonds, 52 cards. Dependent event, the one big difference is that the probability of me drawing the Jack of Spades was 1 out of 52. Now the probability of me drawing that Queen of Diamonds is 1 out of 51, because you're missing that one card from first. And that's it. So remember, guys, you can reach out to me on Zoom. You can text me, email me if you have any questions. Rewatch this video and kind of pause it at parts where you might have questions, and you can comment on the video. And good luck.